This conference will now be recorded.
Okay. So, good evening, student. Today we'll be learning about the nature and the source of the electromagnetic wave. And of the so the detection part I'll just mention today. This detection of electromagnetic wave I'll discuss in detail source, nature of the electromagnetic wave. So let us start. So and magnetic field. Okay. So electromagnetic wave is a combination of both electric field and magnetic field. Okay, so yeah, madam, what about audible still? Still, I'm actually speaking.
Yes, yes, okay,
Can you
okay.
reply?
Yeah, yes, yes, Ram. Can you hear me?
Hello.
Yeah, Ram.
Okay.
Can you hear me?
So voice is breaking.
Yes,
I can hear, but is this the case for me also? Is the
no,
voice is breaking for me? Like
it's
while
breaking. Yes, sir.
yeah,
Voice
actually,
break.
sometimes practically I'm not able to hear.
Stop. Sometimes.
Yeah, yeah, practically I'm not able to hear you clearly. Here, 10 minutes, another 10 minutes. So from the starting,
But Deepa can hear
yes,
it
I
seems.
understand, madam. I understand. So for the is Deepa hearing? Deepa, can you?
This conference will now be recorded.
Okay, so Deepa, today we'll be learning about the source and the nature of the electromagnetic wave. So before we learn what is source and the nature of the I'd like to first define what is magnetic wave. Would like is electromagnetic wave of both okay, and very soon that electromagnetic wave is a self-sustaining wave and self-generating wave. Okay, and this electromagnetic both electric and magnetic field. Okay, let us see what a static charge can produce. Static charge we have learned already in the first chapter. Static electric field. Static electric field, right? Static electric field. What about so charges moving? That means a steady current. So charges when charges moving with uniform velocity or uniformly, that means it is actually a steady current. So what about steady current? So what does a steady current do? A steady current produce only magnetic field. Okay, magnetic field. Okay, only magnetic field. And this magnetic field not vary with time or with space, but we'll see electromagnetic wave it varies both time and space. Okay, so we have seen that static charges can produce static electric field, so which we know as E. Okay, it has a space variation, but static in the sense it does not have variation. And charges which are moving with uniform, and that's the velocity, they produce a steady current. Steady current will produce a static variation. So this is why it is called steady. Steady in the sense static, or steady in the sense there is no variation with respect to time. But We know electromagnetic wave, which is a combination of time and space varying electric and magnetic field. A source of such electromagnetic wave is accelerated or oscillating charged particle. Accelerated which is in oscillating charges. Okay, so both are actually time and the sources of space varying electric and magnetic field. I'll tell you a charge particle, not but a charge which is moving with an acceleration can already restored. I don't know how to continue with this. Let me continue. Accelerated or so oscillate electromagnetic wave. I'll explain how it is. Okay. So suppose I have a charge particle which is oscillating. This oscillating particle will radiate electromagnetic wave. So you might be thinking, sir, oscillating charge particle may create electric field.
தலைவலி இந்த பக்கம் ஒரு பக்கமா எடுத்து போ.
What it does actually, it produces oscillating electric field. Okay, oscillating electric field means it has, so the oscillating charge particle will produce we have learned in the last class from the displacement current, that section Maxwell had established that oscillating electric field produce displacement current, and that current is actually producing an magnetic field which is oscillating with time and space. Okay, so see what happens when there is a charge particle which is accelerated or oscillating. Both are equivalent oscillating. or an electric field which is time and space. So we have learned varying electric field. Varying electric field can create current. Magnetic field can create oscillating electric field, and it will be regenerative process. I'll just explain once again. See, oscillating or accelerated charge particle, varying displacement current. Okay, displacement current. A space varying magnetic field. Okay, time and space varying magnetic field or varying magnetic field. I can say this is varying magnetic field or oscillating magnetic field. Oscillating magnetic field. Oscillating magnetic field I'm writing as B. B is like magnetic field is denoted by B, so I'm writing as B. So when I have oscillating magnetic field, it will be continued ID, then go ID will create again B, okay, which is having B means magnetic field, which is having both space and time variation. So I'll repeat a displacement current which produces an oscillating magnetic field. Oscillating magnetic field will create oscillating electric field, and that electric field in turn again will regenerate the magnetic field. So you can see electric field is generating magnetic field, and Electric field is generating electric field in turn. Okay, so this is how electric field will regenerate themselves. So electric field, time varying electric field will generate time varying, sorry, oscillating electric field will generate oscillating magnetic field. Oscillating magnetic medium. Okay, they don't require any medium. So this is how Maxwell's equations and from
Ram,
his
sometimes
mathematical,
you
rigorous
can't hear.
mathematical derivations, he could that there
Ram,
is an electromagnetic wave. Sorry,
Ram, sometimes we can't hear you, Ram. Middle and all is stopping. I can't hear the voice. Deepa also faced the same problem. She's not
yeah,
telling
this
at all.
no, madam. Actually, I'm not able to hear your
Yes, yes, here
complete
Chennai
word.
heavy
I have
rain.
understood what you.
Yes. In
No,
Ram,
I understood
issue.
what you are saying. Sometime both of you are not able to hear. Actually, I'm seeing the message that my audio network issue. I don't
Okay.
have anything in my hand. Uh, I'll see. What I'll do. I'll I'll just continue another 15 minutes. At least I'll finish this part,
Okay. Okay, Ram. Okay.
and I'll stop it today. Okay, since Deepa has come. Okay,
Okay.
I'll repeat this coding in website. Okay, yeah.
Okay.
Since Deepa has come, I'll just teach her another 15 minutes so that actually please excuse me for the sound quality today. I actually I'm trying my best, but there is some network issue. Anyway, so maybe that is also another issue in particle or accelerated charge particle is the source of electromagnetic wave. So far we have established that. Now what to do? Now what yes. So what we'll do? We'll see electromagnetic wave, uh, but experimentally how to prove this. So Hertz is the person or the first person to scientist Hertz of electromagnetic wave is abbreviated as EM wave. Today we'll just learn the nature of the electromagnetic wave. Okay, Deepa will discuss this experiment later in detail. Okay, Lalta. Okay, so we'll learn now nature of the electromagnetic wave. So the nature of the electromagnetic waves we have somewhat described. It is produced by oscillating or accelerated charged particle. So frequency number one. So electromagnetic wave is self generated and self propagating. Okay. Then second point is, so self propagating in the sense it does not require third is electromagnetic wave transverse in nature. In nature. Okay. Transverse in nature. So what do you mean by transverse in nature? In general, longitudinal and transverse wave. Or EM wave. Okay. Or even you can produce in the string also. Okay. In the string also you can produce transverse wave in the string. I'll explain longitudinal wave actually is propagating due to, or it is due to rarefaction and compression of the medium particles. Okay. So see, in case of longitudinal wave, the wave, like propagation direction of the wave. So suppose I say so, in this case, longitudinal wave of the wave. Okay, they oscillates in the same direction. Suppose my wave is propagating in this direction. This is the propagation direction. Propagation direction of propagation, and oscillates in this direction, okay, in this direction, but wave is propagating in this direction, okay. That means if the oscillation of the particles of the medium for propagation, so when longitudinal wave propagates, the material medium particles in the medium oscillates in the same direction as the I think now it is uh, i- yeah, so a bit about it. Look, this this is the typical representation of electromagnetic wave. So this is a transverse wave oscillating along the y direction. So x, y, and z, so they are actually mutually perpendicular. So the angles are 90-degree. Okay. So along this y progressing, the wave is actually progressing along z direction. Okay. Look here. The waves are oscillating in the direction perpendicular to the propagation of direction of propagation of the wave. Okay, so here mutually perpendicular to each other, cooler to each other. To the direction of propagation is propagating oscillating along x direction, b is oscillating along y direction. But what about the em wave? The whole wave, if I say uh, you can see this ex is perpendicular to by because it is oscillating along the y direction, and they are individually perpendicular to the propagation direction, like one of the nature of this electromagnetic wave. And this is very important. This particular point is very important. You have to remember, because you will be able to solve numerical problem from this point. I'll just give you the equation for this electron because it is oscillating along x direction. What I have to write? Suppose it is having some magnitude E0. So I can write as sine or cosine term. Sine omega t minus k z. Okay, is the issue. See here you have to note one point that this is an electric field or electric wave which is oscillating along x direction, but it is propagating along z direction. The whole minus kz, that means it is propagating along positive z direction. Positive z direction. So this is the thing. Positive z direction. And then I'll write B electromagnetic wave, like component of the electromagnetic wave kz. Okay, kz. So in this case, you can see the wave is propagating along the along the. So this kz is representing the propagation of the whole electromagnetic wave, whereas your By is denoted. So this is the thing. Okay, wave is combination of an electromagnetic wave these two wave. And you can look one more thing that this also. And what is this k? K is actually called propagation vector 2 pi by lambda. It is called propagation vector. Propagation vector. Propagation vector. Okay, propagation vector. It is propagation vector. One wave you will get by doing omega by k. This is the speed of the EM wave of on Wednesday. Okay, I'll repeat this class on Wednesday with more clarity because of this sound issue, like this network issue. We are a bit disturbed today. Guna madam, I'll stop it here today because it is too much disturbing. I'll repeat this class again. Okay. All right. Bye for
Okay.
today, Deepa.